Welcome to Solving Derivatives with Paola, Diego, and Carla. Today, we are going to learn more about getting the equation of the tangent line. First of all, let's learn some basics. The tangent line is a straight line that just barely touches a curve at one point. The idea is that the tangent line and the curve are both going in the exact same direction at the point of contact. The equation of the tangent line of a function at x equals c is y minus f of c equals f prime of c times x minus c. And with that, we can see certain similarities with the point-slope form to get the equation of any function. The point-slope form is the following: y minus y1 equals m times x minus x1, where y is the y-coordinate of a given point, x is the x-coordinate of the same point, and m is the slope. So we can identify that f of c is y1, c is x1, and the slope is the derivative of the function. It's important to visualize that every time you are asked to get the tangent line of a function, you should have the function at the x-coordinate of the derivative. And how do we get the tangent line of a function? Or which steps can we follow? Well, there are 4 steps you need to follow to achieve it. Step 1. Get f of c. You just need to substitute for c in the given equation and you'll get it. Step 2. Get the derivative of the function. Step 3. Get f prime of c, using the result you got in step 2. You should substitute for c in the derivative of the function. Step 4. Now that you have all the needed values, it's time to use them in the point-slope form. Y will be f of c, m will be f prime of c, and x will be c.
Let's see an example to understand this better. Example 1. We need to get the tangent line of f of x equals x squared plus x plus 3 when c equals 1. First, let's get f of c, which will ultimately be y1 in our tangent line formula. Since c equals 1, we substitute x for 1, getting f of 1 equals 1 squared plus 1 plus 3. We solve our expression and have that f of c equals 5. Now, in step 2, we'll have to get the derivative of f of x. We'll need to use the power rule to get the derivative of this expression. X squared becomes 2x, x becomes 1, and 3 becomes 0. Therefore, our result is 2x plus 1. In the third step, we need to evaluate the derivative of f of x when x equals 1. So, we plug in our value and get the following expression. F prime of 1 equals 2 times 1 plus 1. And we get 3 as a result. This will be m, our slope, in the tangent line formula. Now, for our last step, we substitute the respective values for y1, x1, and m in the point-slope formula, and we get the following equation. Y minus 5, which we got in step 1, equals 2, our slope, times x minus 1, which is our result in step 3. We do this derivative property and get the following equation. Y minus 5 equals 3x minus 3. Now, we leave y alone, resulting in y equals 3x plus 2. This is the equation of our tangent line. But how is this represented? Let's graph the equation with its tangent line. Our original equation is f of x equals x squared plus x plus 3, and its graph looks like this. Now we have that the equation of the tangent line at x equals 1 is y equals 3x plus 2. We locate our x value, in this case 1, in our graph and draw the tangent line. Remember that the tangent line must only touch one point in our graph. If you're hesitant about the direction of your tangent line, remember that it should mimic the direction of your x-coordinate. For example, in this case, the graph is increasing at x equals 1. Therefore, we know that having a positive tangent line equation is correct.
Example 2. We have f of x equals x squared plus 1 all over x squared minus 3 at c equals 2. First, as we did before, let's evaluate f of c to get what will stand as y1 in our point-slope formula. F of 2 equals 2 squared plus 1 all over 2 squared minus 3, which results in 4 plus 1 divided by 4 minus 3, and gives us a result of 5. Now, to get the derivative of f of x, we need to use the quotient rule. Our u will be x squared plus 1, therefore our u prime is 2x. We get it with using the power rule. The b value is x squared minus 3 and b prime is equal to 2x. We need to use these values in our quotient rule formula. B times u prime minus u times b prime all over b squared. So we get 2x times x squared minus 3 minus 2x times x squared plus 1 all over the expression x squared minus 3 to the square. We can take 2x as a common factor and simplify the function as 2x times x squared minus 3x squared minus 1 all over x squared minus 3 to the square. It can be then simplified further as 2x times negative 4 all over x squared minus 3 all to the square, and then as negative 8x over x squared minus 3 all to the square. This is the derivative of f of x. Now for step 3, we need to evaluate the derivative when x equals 2. This will stand as x1 in our point slope formula. Evaluating f prime of 2, we get negative 8 times 2 all over 2 squared minus 3 all to the square, which will result in negative 16. This is our slope. With y1, x1, and m, we can get the function of the tangent line. So we substitute the values and get the equation. Y minus 5, which is our result in step 1, equals negative 16, our slope, times x minus 2, which is our result in step 3. We use distributive property and get y minus 5 equals negative 16x plus 37. We move the minus 5 to the other side of our equation in order to leave the y alone and get the following equation. Y equals negative 16x plus 37. This is the equation of the tangent line. But how is this represented? Let's graph the equation with the tangent line. Our original equation is f of x equals x squared plus 1 all over x squared minus 3, and its graph looks like this. Now we have that the equation of the tangent line at x equals 2 is y equals 16x plus 37. We locate our x value, in this case 2, in our graph and draw its tangent line. Remember that the tangent line must only touch one point in our graph. And now we're done. We hope our examples were helpful when understanding how to get the equation of the tangent line in a certain point.